You are about to be fixed. Physics Fixed. Better than real. Where each brief episode brings insight you've never had before by smashing through conventional barriers. It's Occam's razor in the hands of Jack the Ripper. Previously, spin½ was identified as chronaxial, about a fermion's timeline. Such three-plane rotation is solid angular, entailing 4 pi steradians. That's 41,253 square degrees. Fermions, such as electrons, have a property called probability amplitude that inverts with 360 ordinary degrees of rotation and after 720 degrees returns to its exact initial state, like a pencil sliding along a Mobius strip. Yet physics denies a physical model for this. That's about to be fixed. Of note, probability amplitudes are extremely abstract, and it is not at all obvious what their physical significance is. You will have to brace yourselves because it is absolutely ridiculous. The most shocking characteristic of quantum electrodynamics is the crazy framework of amplitudes. You can have all the philosophical worries you want as to what the amplitudes mean, if indeed they mean anything at all. But because it agrees with experiment, it's good enough. We invent an arrow, which we call a probability amplitude, because we do not know what it means. Nobody knows any machinery, and no one can go any deeper today. Probability amplitudes are very strange. Probability amplitude is the source of the mysterious consequences and philosophical difficulties in the interpretations of quantum mechanics, topics that continue to be debated even today. Has anyone told the particles, which all employ this property, that they should doubt its physical significance? Physics isn't physics if it denies the physical. The Born rule gives probability p as the square of a wave function value for a particular measurement. That value is the probability amplitude a, which is conversely seen as the square root of a probability, a source of continued confusion. There have been many attempts to derive the Born rule from the other assumptions of quantum mechanics, with inconclusive results. Feynman illustrated A as an arrow marking the side of a square for which the area is p. I commend his geometric approach, but the arrow was unidentified physically. Until now. For fermions, the probability that the signs of prepared and subsequently measured spin components will agree relates to the angle theta between them. Specifically, probability p is cosine squared theta over 2. P returns to 1 after just 360 degrees, but A, seen as cosine theta over 2, indeed requires 720 degrees. So what is probability amplitude A physically? We know that a fermion with a prepared spin component will, if subsequently measured on the same axis, exhibit 100% self-correlation, or p equal 1. Thus, probability amplitude 1 is also assigned to that component spin axis. But for different spin components, probability amplitude A is the projection of probability 1 on their shared angle bisector. Thus, A is the altitude of the triangle having equal magnitude spin component sides. So clearly, A equal cosine theta over 2 is still a probability, not a square root of probability. Correlation probability is the projection of that amplitude on the subsequently measured component axis, or cosine squared theta over 2. Note that as theta increases to 180 degrees, the amplitude decreases to 0. Beyond that, eversion of the triangle yields an increasingly negative amplitude to 360 degrees, which returns to 1 at 720 degrees. Seeing spin½ as chronaxial, imagine a unit sphere where the radius is 100% self-correlation for any spin component. Two different components are separated not by arc but by area A, corresponding to their solid angle's base. A is proportional to its own radius squared, or sine squared theta over 2. Spin correlation diminishes from 100% as A increases, such that P equal 1 minus sine squared theta over 2, which equals cosine squared theta over 2. But cosine theta over 2 is the altitude of the solid angle's cone, which works the same as before. Holding altitude vertical highlights its change in sign. Halfway around, the cone everts to negative altitude, returning to +1 after another circuit. For spin correlation, Probability amplitude A is located on the central bisector between prepared and measured components. Seen on a 3-plane, a sphere coincides with its circumference as a cone does with its triangular projection. Coming episodes will clarify exactly what aspect of a fermion is doing the spinning. Congratulations! Half-wits rule! There's yet another round to go with spin½ next time on Phyxed. I'll see you there, if you dare. Ha ha! I'm crazy about the Science Asylum. Find a link in the description below.